welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. All right, hi everyone. Welcome to the House of ZK special. I'm Alice. I'm a host at House of ZK here, and welcome to the first episode of our second series on the ZK industry leaders. So we're joined here today with Vanishree from Fermah, and the topic of today's discussion is on proof markets. So we'll be diving all into that. Thank you so much for being here today, Vanishree. We're really excited to have you back here on House of ZK.
Thanks, Alice. Always a pleasure to talk to you.
Yeah, thank you. So to kick off this discussion, I'm wondering if we can speak a bit about first the why behind Fermah. Fermah's building a universal proof market. So I'm wondering if you can give us some more insight on what the concept behind a universal proof market entails and any kinds of specific advantages it provides in the proving space.
Mm-hmm. Before cloud was a thing, imagine having to do everything on your own, deploying your own infrastructure, right? When ZK started getting adoption, such was the problem faced by people who were trying to adopt ZK. There were basically two problems. One is the onboarding problem, and the other one is ongoing problem. Onboarding problem is how do you adopt ZK, and then how do you stay adopted with ZK is the second ongoing problem. Onboarding problem is largely solved with ZK VMs because they make writing code and proving easy. But ongoing problems are, how do you price compute? How do you price proving? How do you upgrade your proof system to the new one out there? Because ZK is ever evolving, so fastly evolving. You don't want to be stuck with the one from yesterday. How do you how do you orchestrate different steps of proving within how do you build that orchestrator? There are so many problems, ongoing problems, that every single project that decides to integrate with ZK faces. And we thought, okay, this is the time where everybody needs a one-stop infrastructure for ZK proving. And the one-stop infrastructure is what we are building at Fermah, where you remove all the headaches I mentioned of ongoing issues of adoption with ZK.
Yeah, and it's really great that you mentioned that there's kind of these different steps of proving, and one consideration that teams need to figure out is how to orchestrate them. Proving is not just like a one-step part of the ZK life cycle, but there's actually different nuances that needs to be figured out. And it's great that Fermah's vision is to have some sort of infrastructure provided for these teams and make it feel like it's just a one-stop kind of thing, so that you can streamline that process when it comes to proving. So I really like the initiative that Fermah is going for over there. And I was also curious to hear more about the need for proof markets today, especially as the demand for new proofs to be generated is increasing. We have a lot of new initiatives going on, even with, for example, the real-time proving initiative, trying to generate these proofs that prove the execution of mainnet blocks in real time. So curious to hear about the need for proving, for proof markets today, and how they compare to, say, like some proving services that maybe some other projects offer that are more centralized. And also curious to hear as well about your original conviction of proof markets and how that eventually played out there. So I wanted to hear that aspect as well.
Oh, yeah, these are great set of questions. This is I think you started off asking where proof markets have a place in this whole industry, in this whole why do we even need proof markets? In terms of how people generate proofs, right? There are of course different ways of generating proofs. You can deploy your own network of GPUs, or if you have less demand, you can have a couple of GPUs in-house that just do this all the time. And you can work with AWS or decentralized providers. There are different ways. And then there is this other way of working with a proof market. Where is the difference? The difference is in the difference is in scalability. You can have a scalable solution. The difference is in upgradability. You can have an upgradable solution because Fermah is a universal proof market. You can upgrade very easily. While having the same infrastructure, you need to have the same infrastructure, same pricing mechanism when you upgrade the proof system. If you hop from one proof market to another proof market just to switch your proof system, it's a nightmare. You need, like I also mentioned in the beginning of our discussion, another important aspect is how easy it is for you to work with whatever proving service you use in terms of the whole UX, your cost predictability, your proving time, and and the reliability. So these are the things that you anyway care about. What are let's recall: time, cost, upgradability, and reliability. So let's break that down. How proof markets win there and other solutions don't win. Time is mostly determined by the algorithm that you run, not by the proof markets themselves. I think there is this very big miscommunication in the industry that, oh, this is a proof, this proof market will, let's check whether this proof market will run things fast or not. The primary, the determining factor is the algorithm and the hardware that you run. And if you have that hardware, if you have that code, there is negligible amount of time taken in orchestration. I think orchestration, it is hard to do orchestration bad that you'll take significant amount of time and be worse than other competitors. So that is not the indicator of how good a proof market is. So among the things that people care about: time, cost, and cost predictability, upgradability, and reliability. So the second one is cost. The cost is dependent on a few things, mainly two things. One is, what is the machine that you have and where are you getting it from? Is it from AWS, from a centralized provider that tends to have a huge gross profit margin? 80% gross profit margin, of course, you'll end up having to pay more, and somebody needs to open up their pockets. It's typically the end users. And if you use, on the other hand, if you, on the supply side of your market, have machines provided by people who otherwise don't use it in general, it's lying idle and they're letting it get used. It's the Uber model. And so if such is the case, then the price that you can set in your marketplace is much lower, at least 50% lower is what we have seen. Cost predictability comes from the kind of mechanism you have, the fee mechanism you have. This is one of the biggest differentiators a proof market can have. This is the vertical in which a proof market can differentiate itself. Mechanism design. And we, for a very good reason, haven't published the way we are doing our mechanism design. And it is because we believe it is the best. There is no reason for us to give it out, and we want to hold it to our own. Our customers know it, we know it, we work with it. It is great. So this is for now we are not publishing it. So that's about cost predictability. We have a mechanism design where you can have cost predictability. And the third one is upgradability. You can get upgradability, like I said, in a universal proof market, not in a proof market that is built otherwise. In a universal proof market, on Fermah specifically, let's say you're using proof system 1. Let's say even the same team has upgraded its proof system to a different proof system. Maybe has made, let's say the end was Grot 16, the recursion step was Grot 16, and now they have flipped it to Flunk. Such an easy thing to do on Fermah. Everything is a workflow on Fermah. In this workflow, there is a step that you change so easily. In our SDK, you just change so little that upgradability is so seamless on Fermah. Same mechanism design, same pricing, same integration. You don't have to worry about integration again with another proof market. And fourth one is reliability. Reliability comes from how strong your network layer is, how what is the quality of machines you have on the supply side, what kind of uptime are they giving you, what is the level of scalability you have, etc. All of these are possible in a great way in a proof market, especially in a universal proof market.
Got it. So some of the differentiators for universal proof markets as opposed to some of those, for example, centralized proving services, is that for Fermah specifically, the team really values the scalability aspect, the upgradability aspect, and being able to have that same integration, the same mechanism design, the same pricing, even if one were to upgrade their proof system. And then also another aspect is on the user experience side. So that's relating to the cost predictability, as you mentioned, the proving times, and then also the reliability and the upkeep of the network.
Yes.
Got it. And on that point for the upgradability part, which you mentioned, like, for example, if this feature were not to be present, having to go from one proof market to another proof market just to switch the proving system is such a headache. And for universal proof systems, like for Fermah, you can have that same integration whenever a user wants to change their proof system. So I'm thinking that this is very useful for example, if a user decides they don't need to do any like on-chain verification, so they decide to just use a Stark-based proof as opposed to like a Grot 16 proof. So I'm thinking, for example, like those kinds of use cases, it would be very helpful for them. But 100%. Wanted to hear some more about like the flexibility component of enabling this upgradability piece. What is the importance of building kind of this modular system that is flexible to a variety of these different proving systems? And are there any kinds of other scenarios that you can think of, or any clients or people who have tried out Fermah so far in which it would be useful for them to like migrate from one supported proof system to the other? And you mentioned that process is also pretty seamless as well. So wanted to hear more about that.
Absolutely. I think this is a great direction because it really highlights the expressibility and the usefulness of workflows as a primitive. So the two examples I think would be great to consider are zk-Sync, one of our favorite customers, and we are also working with. We haven't announced it, so I'll keep it. I won't mention their name yet. So they're think of them as a roll-up as a service, and so what happened with zk-Sync? So zk-Sync started with a proof system that they were working with, and now they have a phenomenal new proof system. Its performance is it's just as unbelievable. So this migration happened like this. This is why. The way we integrated this new proof system was, think of it over a weekend, in a few hours. Especially even for someone who does not know what the new proof system is, that person, our integration engineer, looked at the new proof system, its workflow, did it all in a few hours. And the other example I wanted to give is the roll-up as a service platform, where they have these different customers. They have different choices. They are at different levels of maturity, which in different levels of maturity in their choice of proof system. Some of them are probably choosing between one or the other, between two options. In that case, they just want to try two options on one single platform, and a credibly neutral platform which doesn't have one proof system versus the other to really uphold for any other for any personal reasons. Oh, yeah, I think that's worth celebrating. Um, and yeah, I think these are two examples, Alice.
Yeah, that sounds great. From the ZK Sync side, they were able to migrate using the new proof system that
Yeah.
they developed. And for this roll-up as a service example, you mentioned like different customers, they may have different needs. They have different levels of maturity in terms of their choice of the proof system. So it's
Mm-hmm.
really great to provide that kind of flexibility based on the different needs of different users. Yeah, that sounds great. And also, I wanted to ask you more about the overall role that Fermah has in the ZK supply chain. So I know that you have been doing some educational content for House of ZK as well, and one of the topics there is looking at the pipeline for generating and verifying a proof in the lens of a supply chain cycle. So Fermah, since Fermah is a universal proof market, it optimizes a lot for that proof generation stage in that pipeline. So wanted to hear more about also like the role that these prover markets have in the supply chain for ZK and in being able to accelerate this particular step, the proof generation step. How are some of the other parts of this supply chain life cycle affected, like with the proof verification phase as well? Can a proof market also somehow help streamline the verification step?
Yeah, I think this question gets to the heart of modularity needed in different steps of in different steps of proof generation, right? So, like you mentioned, there are different. It goes through a life cycle. A proof generation is a life cycle. Starts with proof generation, maybe some sort of aggregation after that, and then proof verification. The role of a proof market is only generating proofs, not in verifying proofs. But there is some amount of verification. There is verification to some degree done already in the proof market. Why? Because when we give a proof to the requester, we call them a seeker, proof seeker. When we give the proof to them that they requested, we first need to make sure it is sane, it is well computed, right? And the way to do that is by running the verifier. That is why we run the verifier and give it. And you asked a very interesting question that because we are already verifying, can we act as a verifier, a settlement layer, so to speak, a verification protocol, so to speak? The answer is no. Why? Because a proof market has, because of its goal, it has its own notion of correct behavior. And our goal is to enforce that correct behavior. A verification protocol has a different goal, and it has, and its way, and the way it works, everything is optimized around ensuring that they do that correctly. These are two different goals, and let's go one layer deeper. So the way we verify is we verify it in a centralized manner, right? So there is this centralized matchmaker who orchestrates proofs, gets it, we check whether it verifies or not, and we give it. It's totally fine to do it on a proof market because our goal is to generate the proof somehow. Whether I do it, whether I do it with a verification in a centralized setting, whether I do it verification in a decentralized setting, it does not matter to the seeker. The seeker only cares about the proof getting generated correctly, and this goes down to this powerful property of proof systems that it's sound. if you generate a proof, we don't care about how you generate the proof. You do your magic, you go do a somersault, you go to the moon, generate proofs and come back. I don't care. Only if you give me a proof that verifies, I'm happy. So it really, once the verifiable proof comes out, there is nothing that a proof market can guarantee beyond that, and beyond that to the seeker. Now the seeker needs to have it verified elsewhere. So that elsewhere has to trust the system to say whether it's verified or not. It can't be a proof market. It has to be something else that is designed to do that. So projects that are verification layers, they do this by having some sort of their own optimized consensus across a decentralized network of verifiers that verify proofs. So it's a completely different goal, which needs a different approach for compute, and hence these need to be separate. Gladly, they are separate. We are a proof market, and this is this very well defined role for proof markets and very well defined role for verification layer.
Got it. Yeah. Thank you for making that differentiation. There's verification components both within the proof marketplace, but then also within a verification layer. But the notion of what's being verified is different between the two. So for Fermah, there is some sort of verification aspect before the proof is given back to the seeker. But in order to say like use the proof for any kinds of further applications, the proof verification step afterwards is still needed. And yeah, I can see like for example, some different applications being able to say like delegate their proof generation to a proof marketplace like Fermah, and then potentially being able to deploy that proof to some sort of verification layer. So it seems like right now we're in that state where a lot of the steps within this pipeline is a lot more streamlined, and a lot of the heavy lifting when it comes to the costs or even the time to do the proof generation and also verification is a lot less heavy compared to before. So it's good to hear that how more processes are optimized.
Right. On that note, shout out to two of our collaborators, design partners and also collaborators there, Aligned and ZK Verify. Those are verification layers that are, I think, doing a good job out there.
Yeah, definitely. And yeah, super exciting again to see that different parts of this life cycle are being optimized. So for Fermah specifically, it's the proof generation aspect. And I think we've come a really long way since when we were first working with ZK in this industry. And now we're having these different steps be optimized and really improving the end user's experience. So it's all great to hear. And then I also wanted to ask you about the differences between server versus client-side proving. So I feel like nowadays there's this trend where people are beginning to more commonly just outsource their proof generation, say to a proof marketplace like for Fermah or some other sort of proving service rather than doing the proof generation locally. So I wanted to hear, just from your perspective, any trade-offs that come with between outsourcing these proofs to some sort of external marketplace compared to local or client-side proving, and especially for applications that are, say, privacy preserving. Are there any sorts of scenarios where one approach is more suitable to the other and vice versa? I'm just curious to hear about the specific use cases that are more suitable for proof marketplaces as opposed to doing the proving locally.
Mm-hmm. Great question. If you look at the market for proof generation, you can segment it into two parts, right? One part that cares about privacy of inputs, the witness, and the other part that doesn't care about it. The part that doesn't care about it is the one that has gotten a lot of attention and has had a good level of maturity, and that is with roll-ups and applications like that, where they don't have to care about privacy of inputs to approver. On the other hand, there are use cases one can think of where the inputs to approver need to be kept private. And in those cases, you need to however you generate proofs, like whether it be with the proof market or client-side proving, however you generate proof, you need to do it in a privacy-preserving manner. And like you said, there are two ways. One is on the client itself, because on the client the input is not getting outside it's not going away from the client, so there is no way of losing privacy that way. So that's client side proving, very straightforward. The other one is you delegate it to a proof market, where the proof market actually generates the proof in a privacy preserving manner. And we developed a protocol called Confidential Proving Delegation Protocol, which actually enables proof generation while preserving privacy of inputs. Now, how do we look at the trade-off between these two approaches? Is I think both are valid. I think both have a place. And client-side proving works really well in the situation where your the client devices are big enough to support proving. Many use cases are like that, where you can actually generate a proof on devices, and the problem arises when the application in question wants to really expand to areas in the world where they need to generate proofs on really small devices, old Nokia phones, for example. And it's also problematic when what you want to prove, the compute you want to prove, is big, right? So in those cases, you might want to delegate the architectural solution to proving. In such a case is you delegate to a proof market and ensure that there is privacy in the input while generating proofs.
Got it. So some of the trade-offs involved are relating to the amount of resources. So some of the client devices, they must be big enough in order to support that proving aspect. And for a lot of these user devices, maybe there's just not enough memory to support this client-side proving. And at the same time, you mentioned the large computation as well. Trying to generate a proof for a particularly intensive computation may not be so ideal on just like a single smaller device. So in those kinds of use cases, it makes more sense to delegate the proving externally to, say, a proof marketplace. Got it. And I also wanted to ask you about some of the recent updates happening with Fermah as well. So I know that Fermah is currently in the, I believe, third phase of the testnet, the Bonnet phase. So I'm wondering if there's any kinds of particular takeaways that the team has from this phase as well as earlier phases of testnet, and how these can apply when we're anticipating Fermah going mainnet later this year.
Yeah, I think more than surprises, we had corroborations of our beliefs on really making sure some design elements were covered when we were implementing. One is we need to keep the machines warm for use cases where our customers really care about proving time. So you want the machine to be prepared, be prepped, already prepped. It is useful to give the same command, like, let's say ZK sync, right? Let's say it has 20 steps. The second step has to go to the same machine pretty much every time because it is already prepped for that. The prepping takes time, and it actually shows up in the total proving time. This is probably what the proof market should ensure, and if there are proof markets that don't ensure, then I think it's where they take a hit in the proving time. Otherwise, it is, like I said, it's the machine and the algorithm. Anyway, this was one corroboration of our design that we really focused on to make sure. And the other is we early on try to make sure that any binary updates, they happen seamlessly for our operators, for our prover nodes. Um, that was a good decision. And um, there is a natural, organic inflow of projects wanting to integrate now. Earlier, it was us reaching out, us figuring out, and us trying to convince. And I think right now there is a more of an inflow. Um, um, yeah, I think these are some things that come to mind about summaries of what has happened in the past few months.
Got it. Nice. And very excited to see the next phases of where Fermah goes with its next testnet or onto mainnet. So I think it's a very exciting team for time for everyone involved and for the team. And I also wanted to ask you a bit more about the idea for incentive alignment. And I know in our, like earlier in our discussion, you mentioned that that relates a lot towards the underlying mechanism design for some sort of system like for a proof market. But wanted to hear about any kinds of like specific models or frameworks that you believe are really essential for making sure that there is incentive alignment between the proof requesters who are requesting for the proofs and want to receive fair prices, as well as the provers who these proof requests are delegated to, and any kinds of like edge cases, for example, certain provers being able to monopolize compute in the network, taking on all the proof requests, how Fermah goes about with addressing that. I'm wondering if that's also related to the decentralized component that Fermah really prioritizes on as well. So wanted to hear more about what you believe are like the best kind of models or frameworks that should be followed when it comes to incentive alignment.
Mhm. Absolutely. So I think I there are three characteristics of mechanism design that are of our mechanism design that we really ensured in our design. One is predictability, cost predictability. This is taking care of the UX of the seeker, right? They need some sort of cost predictability, and it also implies that the provers get some sort of predictability on the income, on the revenue. And the other one is, what are we optimizing for? So you can have a variety of mechanism and designs depending on what we optimize for. What are we optimizing for? We are optimizing for cost. That's what we are optimizing for. Another thing, for example, to optimize for is decentralization. That actually leads to a cost non-optimal solution, cost-wise non-optimal solution. In this spectrum, we chose cost being optimal. And here is why. This is a controversial take on the need for decentralization in a proof market. You need resilience, and decentralization is one way, but that is not the only way. You need enough level of decentralization. It's just that please don't go with AWS, and please don't go have your sequencer die if they shut it down. Of course, that should not happen. We should have resilience. That does not mean you have insane amount of decentralization at the cost of making proof generation so expensive, because they need to be around in your network, right? When you say decentralization, insane amount of decentralization, unnecessary level of decentralization, these machines need to be in your network, and somebody needs to pay them to be in your network, and they are in your network, so the supply is more than demand, right? If that is the definition of decentralization, then somebody needs to pay them. Then so the per cost of proof will grow that much. We went away from it. Why? Because imagine there is one provider who takes over all the proof generation. You can have methodologies that can encourage decentralization even when that happens, enough decentralization even when that happens, not through mechanism design, but by saying that, okay, let's say that happens because these people have let's say that happens because these people have um, I don't know, figured out a tiny improvement. We say that okay, there is a tiny improvement possible. Go ahead and figure it out. People can figure it out. They come. Technology is very rarely a mode these days. People can figure out. They come figure out. There will still be competition. Um, I'll say one more thing. Imagine one project taking over all the proof generation. There are two problems with it. One is not being able to, um, if they shut down, then you're not able to get the service back readily. But it is not that bad. So if you think about zk-casing, if you think about scroll, think about all these current examples of ZK, it is okay to take a moment. Okay, it shut down. Switch to AWS right away. Switch to, okay, AWS is down, switch to GCP right away, right? You can do that. This is not the same situation as a sequencer. The need for decentralization in the sequencer network is so much higher. And I would say it's not even a difference of degree, it is a difference of yes and no. Do you need decentralization there? Yes, you do. Do you need decentralization here? No. Do you need resilience here? If somebody comes and takes over, great. You're giving us great prices, great. Let's say it takes them 2 cents per proof, and they're actually asking us to give them for 2.1. It is still fine. Keep doing, because everyone is only able to generate it for 3 cents per proof. You're still amazing. We will give all the proofs to you. Go on until somebody else figures out how to come to 2.1. They'll come to the network. Or somebody else figures out how to, and let's say this centralized service provider, somehow centralized, let's say they still have decentralized network of multiple machines for resilience within their infrastructure. Let's say for some reason they go rogue, or for some reason they completely shut down. Unlikely, completely they shut down. In that case, or actually, here is another case. Imagine they go rogue and they hike up the prices. Okay, now I have your full attention. Now I'm the one who is getting all the proofs. Now I'm going to hike the price up to 4 cents per proof. Well, at that time, it's not that we have completely forgotten. It's not that they can disallow us from re-engaging with the folks who can give us for 3 cents per proof. They'll come, they'll compete. The proofs will go to them. So it's an open market. The reason why it's an open market and you have other solutions right away, and the sensitivity of time to switch from existing networks to centralized providers is not too high. The sensitivity on time is not too high. Is not too high that will disallow this solution migration for us. This is why I think the 3 things that we should care about are cost predictability and revenue predictability, and optimizing on cost, not on any other verticals. And the third one is it's okay for it's actually consciously not optimizing for decentralization. We don't bring that as a requirement in our mechanism design.
Yeah, that's a very interesting perspective that you take, and it's great to see or hear about how you go about with addressing that trade-off plane that often comes with cost and decentralization. So the vertical that Fermah is most closely optimizing for is relating to the cost. And from there, you mentioned that you need resilience, but decentralization is only one aspect. For that, there's other methods of ensuring resilience as well. But mostly how Fermah approaches it is optimizing on the specific cost vertical, and then also incorporating some decentralized aspects on top of that. But the main vertical is relating to costs. So that's all great to hear. And yeah, I enjoyed very much on this conversation and hearing about Fermah's approach from navigating through this trade-off plane and also the reasoning behind some of the design considerations that you and the team made, especially on making this an open market, and then also all of the unique attributes that create a universal proof market and its place in the ZK supply chain. So this is all very insightful, and thank you so much, Vanishree, for being here today.
Thanks, Alice. This was fun.